10, we'll be proving the similarity of triangles. Now let's say we are given two triangles, triangle ABC as well as the smaller triangle EFG. Now they said to prove that the two triangles are similar. Now this must be the case if the angles are the same. This angle is equal to that one, this one is equal to this one, and this one is equal to this one. Now, what do we mean when we say triangles are similar? They share the same angles. The angles in this triangle are the same as the angle in that other triangle, and the corresponding sides are also in proportion. This means that AB over EF must be equal to the same as AC over AG, and that must be the case again for BC over FG. If they satisfy this means that the two triangles are similar. Now, how can we prove that the triangle ABC is similar to triangle EFG? Well, I'm going to draw a line over here. The line I draw this line such that this line over here, let's call this XY. This line AX must be equal to EF, and AY must be equal to FG, and this one over here must be equal to this one. But you don't have to mention the third one, but if you want to, you can do that. Okay, so this is three lines over here. Now what we're gonna do here, we're gonna mention that AX is equal to EF, and this wasn't given to you. You are the one who proved it, so you must give a reason for that, and the reason that we're gonna give it on the second line. Now, because similarly AY is equal to EG, but it wasn't given to you, you're the one who induced it to be equal, you must say by construction. And when you say by construction, you must show the construction lines. So this will be by construction. Now angle A is equal to angle E, and that is given, it's a given statement. Now what do we know about such a situation? When I'm given two triangles such that the angle here and the two sides in which the angle lie between are the same as the angle in the other triangle and the two lines again in which it lies between. What can you say about the two triangles? Well, they are the same. Then I can say that because the angle in AXY, angle A, the same as the angle in EFG, angle E, and AX and AY, which are the sides between the angle A, and EF and EG, which are the angles between the angles between the lines, are the same. Therefore, triangle AXY is congruent to triangle, okay, this must be triangle AXY is congruent to triangle EFG, and the order doesn't matter in congruence. Now the reason for that is side, the angle between them, and the other side. Now we have proved that. Now if this triangle is the same as that other triangle, it means that this angle here must be the same as this angle between, because the triangles look the same, and this one over here, which is also this one, must be equal to this one because the triangles are the same. Hence the circle is equal to that circle over there. Now what can we say? Well, we must say that, okay, angle AXY is equal to angle EFG. Okay, so I'm gonna write it somewhere here. Let me zoom in my screen. So I'm going to say that angle AXY, because I'm representing an angle, I must put a cap. AXY is equal to triangle EFG, angle EFG, sorry. And the reason for that is because triangles are congruent. So you can say congruency of triangles, or by congruence, and then you are done. Now because the angle here is the same as the angle here, therefore these lines here are parallel. Remember, corresponding angles, if angles in an F shape are equal, the lines will be parallel, and that's the same case over here. And I can see that, okay, XY is then parallel to BC, and the reason for that will be what? Will be the converse of corresponding angles, right? So you can put converse, corresponding angles are equal. So now we're now gonna say something about congruence. Let's use the prop theorem now. Because this line is parallel to this line, it must divide the two sides of the triangle in half. What do you mean by that? This means that AX over AB must be the same as AY over AC. And the reason for that is prop theorem. Remember, you must give a reason for whatever you say in geometry. Now, what do we know about AX? We know that AX is equal to EF. So where I see AX, I can put EF. So I'm quickly gonna cancel AX and put EF. But don't cancel in the exam. You must write this on the next line. I don't have space, okay? So where I see AX, I'm gonna put EF. And where I see AY, I'm gonna put EG. So this will be EG. Now invert the order such that you swap the numerator and the denominator on both sides. Now this will now be the case that AB over this AB over EF will then be shown to be equal to AC over EG, and that is what is here. So in other words, you have proved that that is true, okay? And as long as you can prove that two are true, then the third one will also be correct. So AB over EF is equal to AC over EG. And in short, this is how you can prove similarity of triangles. Thank you for watching.